Hey there, Gregory Carlson here for the Calculus Building, and now we are going to learn the quotient rule. And so in the previous video, we found out what the derivative was of two functions that were multiplying. And so this time we're going to find out what is the derivative of two functions that are dividing. And it's going to look kind of strange, but here's what it is. It is the low function times the derivative of the high minus the top function of the times the derivative of the bottom function divided by the bottom function squared. And so I know that looks horrible, but there is a way you can remember it. And the way I remember it is by remembering this little phrase. And by the way, all of these rules you should memorize. The product rule, the quotient rule, the power rule, all of these you should really commit to your memory. So I just remember low D high minus high D low. So low D high D low. You know, put it to a little tune or something. And so notice they both start with low. The top and the bottom both start with low. And then the top is low D high D low. And on the bottom you have low squared. So it's the low times the derivative of the high minus the high times the derivative of the low over the low squared. So how on earth would we prove this? Well, there is a proof using the definition of the derivative. It's a little long, so there's an easier way to prove it using something called the chain rule. So I'm not going to prove the quotient rule right now. We're going to use the chain rule to prove the quotient rule, which we'll learn about later. So let's go ahead and just go straight to it. Let's see how we would use low D high D low over low squared to find a derivative. So here we go. We have 2w to the 6 minus w over w, and we want to find the derivative with respect to w. So let's go ahead and before we do it, let's do this. So you shouldn't always just instantly use the quotient rule, because sometimes it might be easier to like break something up and use the power rule maybe. So like I noticed, for example, that this would be equal to 2w to the 6 over w minus w over w. Okay, so that would be 2w to the 6. You can break this up since we only have one variable down here. So that would equal 2w to the 5 minus 1. Do you see that? 2w to the 5 minus 1. And if you took the derivative of that, h prime of w, we see that the answer would be 10w to the 4. So that's the answer right there. And you can see how easy it was for me to get there with the power rule. So break it up, simplify, use the power rule. It's a lot easier. But let's go ahead and use the quotient rule just for practice. So remember, it's low D high minus high D low all over low squared. Okay? So here's how you would do that. H prime w with the quotient rule would equal the low times the derivative of the high. So ignore this for a second. The derivative of the top would be 12w to the 5 minus 1. So take a look at that. Do you see that the derivative of the high would be 12w to the 5 minus 1 thanks to the power rule? Now in the quotient rule, we now have a minus sign, so it's really important we use parentheses. And we're going to do high times the derivative of the low. So the high, the numerator, is 2w to the 6 minus w, so there's high, times the derivative of the low would just be the derivative of w is 1. This would then all be over the low squared. So notice we don't take the derivative of the bottom. It's low derivative of the high minus high derivative of the low over low squared. So I know that's kind of tricky when you're first getting used to it, but you'll get the hang of it. So let's simplify this a little bit. Distributive property, that would be 12w to the 6 minus w. That 1 doesn't do much, so this would be minus 2w to the 6 minus w all over w squared. Or actually, that should be plus w, because when you distribute this minus sign, it'd be minus 2w6 plus w. So we see that negative w cancels with positive w. And I have 12w to the 6 minus 2w to the 6. So on the top, I'd have 10w to the 6 over w squared. Do you see that? And that cancels, and so we're just left with 10w to the 4. So that is how to use the quotient rule, but as you can see, I was able to get there in just a couple steps using the power rule. And so definitely do the power rule if you can. But if you can't, then here's how you would use the quotient rule. So here's an example of when we would pretty much have to use the quotient rule because we can't, even if we broke this up, it wouldn't look very nice. So once again, we're going to use low d high minus high d low over low squared. So f prime of x is equal to the low times the derivative of the high, and the derivative of the high would just be 3x squared, minus the high, which is this, times the derivative of the low. Now I'm going to just jump this step. We can ignore the 4 because that's a constant number. The derivative of the square root of x is 1 over 2 root x. And I really just encourage you to memorize that. The square root of x is equal to 1 over 2 root x. You can also get there doing the power rule and making the square root have an exponent of a half. And then we would divide that all by the low squared. So all of it, the square root of x plus 4 squared. And I'm going to stop there. I think this is hard enough that we don't need to simplify. This is the derivative of this function. And if you wanted to, you could simplify it a little bit. But I'm not going to. So I know that seems a little tricky. You will get the hang of it. Just imagine if we were trying to find the derivative of this using the definition of the derivative with the limit as h went to 0. It'd probably take 30 steps to get to the derivative of this function. And we were more or less able to get there in one step by just using this low d high, high d low trick. So I hope you're a fan of the quotient rule. Just remember low d high minus high d low over low squared. Just say that 100 times and you should get it. And so here is how you would apply it to this function right here. In the next video, we'll look at some more examples of using the product rule and the quotient rule to find the derivatives of more complicated functions. If this video was helpful and you're enjoying the calculus building, please recommend it to your friends, like and share, and subscribe, and I will see you in the next section.